Okay, 7.4, part 3. So we've used the zero product property, and then we looked at the graph of some of these. We have this last bit, factor polynomials using the GCF. To use the zero product property, we need our polynomials in factored form. So we need to figure out how to get them into factored form. Okay, so what we're looking for is things that multiply to give us that polynomial. Today we're going to do that by factoring out the greatest common factor. Okay, factoring GCF stands for greatest common factor. Okay, so really what we're going to be doing is factoring polynomials using the greatest common factor is going to be undistributing. Okay, this is not actually an accurate mathematical term, but really it describes what we're doing. We're going to be undistributing. We're going to be distributing backwards. We're going to be taking the value out that they both have in common. So first, we need to find the greatest common factor, or more so, okay, the biggest that divides evenly, that divides in evenly. Okay, for example, I think we're just going to jump straight to an example. I think that's going to be the best way is here if we look at this monomial over here. We've got 4x to the fourth, 24x to the third. The first thing I notice is they both have x's. Okay, they both have x's. And there's numbers that go into both 4 and 24 evenly. So I want to figure out what's the biggest thing I can take out of both of these evenly. So to do that, I'm going to look at their coefficients, the number parts. Remember we talked about those coefficients? I'm going to look at the coefficients and I'm going to look at the factors of those coefficients, or more so what multiplies to give me those. So over here I'm going to list the coefficients. I've got 4. What multiplies to give me 4? Well, 1 times 4, I'm going to create an organized table. I'm going to do it in order. 1 times 4, and then I'm going to try 2. Is 2 times something give me 4? Yeah, 2 times 2. But then now I know this. I've got a 2 over here and a 2 over here, so that tells me that that's the farthest that can go. So the only factors of 4 are 1 and 4 and 2 and 2. I'm going to do the same with 24. 24 has way more factors. So 1 and 24, 2 times what? If you don't know, divide 24 times 2. 2 times 12. 3 times, if you don't know, divide 24 times 3. If it doesn't go evenly, try something else. 3 and 8. Okay, 4 and 6. 5 doesn't go. My next number is 6. 6 is already in my list, so that tells me I'm done. So I'm looking for the biggest factor they have in common. Greatest. I'm looking for the greatest common factor. What's the biggest number they both have in their list? 4. So that tells me my greatest common factor between 4 and the 24 is 4. Another way of checking this is pick the smaller of the numbers, 4. See if it goes evenly into the 24. If it does, that's your greatest common factor. 4 goes evenly into 24, so it's 4. So I know for my coefficients, my greatest common factor is the 4. Now we look at the variable parts. So now we're going to look at the variable. Here we have x to the fourth. Here we have x to the third. So really, I've got 4 x's multiplied here. Here I've got 3 x's. What's the biggest they have in common? Okay, well, these 3 can match up with these 3, but this one's got an extra that this one doesn't have. So the biggest they have in common is 3 of them. So it would be x to the third. So my greatest common factor is 4x to the third. Okay, now I need to figure out 4x to the third times what gets me back to here. So I look at 4 times what gets me 4. Well, that's just 1. X to the third times what gets me x to the fourth. Well, I've got 3 x's. I need 1 more. So times x. There's a plus sign, so we're adding. And then 4 times what gets me the 24. Well, over table here, we did 6. And then I've got 3 x's. Well, this one's already got 3 x's. So what we did here is we just now wrote it as 4x to the third times x plus 6. So we have my two factors. There's one factor, there's the other. I always suggest at this point you check it by multiplying it in. Meaning, take 4x to the third times x plus 6, distribute it in. That gives me 4x to the fourth. 4 times 6 is 24, 24x to the third. Did that get me back to where we started? It did. So that tells me I found it. This is my factored form right there. Okay, so that's, again, factoring out that greatest common factor. So sometimes we'll have to do that first to solve it. Now that I have it all factored out, if this wasn't an equation, we could solve it. At this point, we're just factoring. Okay, on the next ones, okay, so here we're solving 2x to the second plus 8x equals 0. One thing to notice, this isn't like our last video, it isn't like our last section, because this right here is in standard form. Okay, it's in standard form. For me to be able to solve it using our zero product property over here, I need it in factored form. I need it to look like this. Right now it looks like this. So this is where we're going to use the trick that we just learned, factoring out the greatest monomial factor. So we're going to look here. We're going to look at this bit, and we're going to look to see between my two monomials. There's monomials, 2x squared. Here's the other one, 8x. We want to find the greatest common factor. So first look at the coefficients, 2 and 8. What's the biggest number that goes into both 2 and 8? We can list our factors out if we need them, like we did over here. But since 2 goes into 8, I know it's 2. Okay. Now we look at our variable parts, the x's. Okay. So now we want to look at the variable parts. So this one has x squared. This is 2 x's, x times x. This is only 1. What's the biggest x's they have in common? Just the 1x. Okay. And now we need to come up with what it's multiplied by. So I need to ask myself, 2x times what gets me that first term, that 2x squared? Well, I'm missing 1x, so there's going to be an x. Because 2x times x, if I distribute this in, 2x times x is 2x squared. Okay. Then plus 2x times what gets me 8x? Well, I've got my x's okay, I just need a 4, so plus 4. Now I'm going to distribute this in and make sure it works. 2x times x is x squared, 2x squared. And 2x times the 4 is 8x. It worked. Okay. So I'm not done. All I did is got it in factored form. I still have this equals 0 bit. But now that I have it in factored form, I can do what we did the last section, the last part, and set each factor equal to 0. There's my two factors, 2x and x plus 4. So we're going to set each of those equal to 0. So 2x equals 0, or x plus 4 equals 0. Here we'll divide both sides by the 2, x equals 0. Here we'll subtract 4 from both sides, or x equals negative 4. So there's my solution, 0 or negative 4. And then I always, at this point, like to go to a calculator and make sure it worked. Okay, so I'm going to plug in the 0 for x, 2 times 0 squared plus 8 times 0, and make sure I get 0. That one worked. And then we'll go 2 times negative 4, oh, better put that in parentheses, negative 4 squared plus 8 times negative 4 is also 0. So those both worked. I got 0 for both of them. Job well done. All right, next. Okay, this one isn't set equal to 0 yet, so I have to do that one first. The only way we can solve these is if they're set equal to 0. If they're not set equal, we're just going to have to do that step first. So here, my first step is I'm going to subtract this 15n to both sides. So I have 6n to the second minus 15n now equals 0. Okay, so step 1, set it equal to 0. Step 2, I need to get it in factored form. So I need to factor out the biggest monomial factors. So 6 doesn't go into 15. So I'm going to list my factors of 6, 1 and 6, 2 and 3. That's it. List my factors of 15. 1 and 15, 2 doesn't go into 15. 3 and 5 does. So what's the biggest one they have in common? Looks like the 3. So 3 is one I'll factor out. Now look at my variable parts. Here I've got 2 n's. Here I've got 1. The biggest they have in common is 1n. So 3n times what? Again, we want to distribute in and get this 6n squared. So I'm going to multiply 3 times the 2, and I'll need 1 more n. Now multiply it. 3n times 2n is 6n to the second. And then I want a negative 15n, so I'm going to have a negative. 3 times what is going to give me negative 15n? So 3n times what? Give me that negative 15. Well, negative 5. I don't need an n. I've already got the n right here. Okay, now we want to double check it. 3n times 2n is 6n squared. 3n times negative 5 is negative 15 equals, then equals 0. So now I have my 2 factors. I've got my 3n factor. I've got my 2n minus 5 factor. So I'm going to set each factor equal to 0. 3n equals 0, or 2n minus 5 equals 0. Solve each one. Divide this one by 3. N equals 0. Or this one I'll have to add 5 to both sides. 2n equals 5. Divide by 2. N equals 5 over 2. So my solutions are 0, 5 over 2, curly bracket. Okay. And then let's go to calculator and try it. Let's put it over here. Okay. So I'm going to try it back in the original. So 6n to the second. So 6 times 0 to the second. Is that the same as 15 times 0? Yes, it is. Got me the same thing. Okay, so now let's do 6 times 5 over 2. Oh, that second power needs to go out here to the second. Oh, gotta get rid of that in there. All right. Doop, 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 doop. Okay, to the second is 37.5. Is that the same as 15 times 5 over 2? 37.5, it is. So 5 halves and 0 both work. We checked them, we're good. Okay, goodbye calculator. All right, your last bit of practice problems. My calculator doesn't seem to want to go away. There we go. Your last bit of practice problems here is page 381, 26 through 40 even, and then do 49 through 52.